In this tutorial, we're going to go ahead and read data from a graph. So there's a line graph given, and we're going to answer some questions concerning this line graph. The group that this skill belongs to, since we're only going to answer a few questions here, is arithmetic into a little bit of algebra just because we have to be able to read a graph. The skill that we're practicing is we're given a graph representing some situation or an application. We need to read values from the graph and state properties of the graph. Then prerequisites for this skill are understanding units of scale. That means the units for the axes and the scale of the axes. You should be able to read a graph and interpret information from an application and state your interpretations clearly. Very big skill actually for this style of problem. So let's say you're presented with this application that this line graph shows the number of cars in a parking structure from 6 p.m. to 12 midnight on a Saturday. So as you can see, the scale for the vertical axis here is in hundreds of cars, and that's very important for this situation. Also notice something here. There's a break in the horizontal axis. That means that essentially if you count backwards, like represents 12 midnight, this is 11 p.m., 10 p.m., 9, 8, 7, 6, and then they skip all the values, 5, 4, 3, 2, 1, that type of thing, just to get to the vertical axis. It's a very common tactic when you don't really care very much about the previous data. Since we know that the horizontal axis represents the time and the vertical axis represents the number of cars in hundreds, we can now approach answering some questions about this situation. Use the graph to estimate the number of cars that were in the parking structure at 9 p.m. The number of cars is represented by the vertical axis, and the time is represented by the horizontal axis, like we stated. And we want to look at 9 p.m. and estimate the number of cars at that time. So I draw a vertical line up from 9 p.m. to hit the graph, and I'll draw that over to see where it hits the vertical axis. So I'm looking at what number that corresponds to on the vertical axis. I see that when the time is 9, we have the number 3, which represents the number of hundreds of cars. So in reality, we have 300 cars. So at 9 p.m., there were 300 cars parked in this parking structure. The second part B here, is asking us to estimate the time when the parking structure had 500 cars in it. So instead of being given the time and having to estimate the number of cars, we're being given the number of cars, and we have to estimate the time when that occurs. So 500 cars occurs right here. I'll go ahead and draw a horizontal line over. That looks pretty horizontal enough to me. And then we'll see what time that corresponds to. Let me just plug this in here. It looks to me as though the time when there was 500 cars in the parking structure was roughly around 7 p.m. Because, again, we drew a horizontal line from 500 to the line here, and then found out what the corresponding input was. It looks to be about 7 p.m. So 7 p.m. Now the next part is asking us to determine when the parking structure is empty. According to this pink line here, when was the parking structure empty? Now the number of cars that are in the parking structure when it's empty is 0, right? So this is 600 cars, 500, 400, 300, 200, 100, and then no cars. So let's find out when our curve or our line reaches a height of 0. That occurs right there, and that is midnight, 12 midnight. It's just interpreting data from a graph, that's all. But the hardest part for most students is this last little bit. What are the units of the vertical axis? The vertical axis is the one going up and down, and the units are hundreds of cars. By the way, the units for the horizontal axis are the number of hours that have passed. So that's how you do a problem like this. Now there's quite a few more questions we can ask, and I might do that in a different video.